Hi, this is Zach Semke with Passive House Accelerator, and thanks for tuning in to this special bonus episode of the Passive House podcast, recorded at Passive House Network's 2023 conference in Denver, Colorado. And a big thank you to EnerSign for the support of the series. The interview you're about to hear was hosted by Mary James, our Director of Publications and co-host of the Passive House podcast.
Welcome Dylan Martello, and he's with Stephen Winter Associates. And can you just tell us what you do? Just give us the basics of what you do there.
Sure. So I am a senior building systems consultant at Stephen Winter Associates and a certified Passive House designer. Been with the company for about 7 years now, and started doing a lot of modeling and on the design side. That's still where I mostly work, is on the design side, but I do dabble in the construction side as well, depending on our project needs. But I now manage, I'd say, anywhere from 10 to 15 projects, ranging from multifamily, mixed use, probably being the most common one, but some more unique commercial projects and some existing buildings as well. Really just seeing them throughout the feasibility phase of Passive House design, getting them through design development and construction documents, and then ultimately being a team member to help transition it into the construction side of it, where we have a full-time construction staff as well, and assisting them throughout construction, doing inspections and testing and things like that. So kind of aware of the project from beginning to end, but work mostly on the design side.
And what percentage of the projects you work on are Passive House buildings?
Oh, that's a good question. I'd say 95%.
And has that shifted over the years, or did you jump right into Passive House when you started?
No, I jumped right into Passive House when I started. So I graduated with my Bachelor's of Science from Stockton University, and a sustainability program there, and knew I wanted to get into buildings and building science, and kind of graciously fell upon the Passive House team that was really growing and starting to grow from the Cornell Tech project back in 2016. And I started exclusively on Passive House projects. And that said, they were unique projects. So one of my first projects was a retrofit of an existing building in Sri Lanka that was totally non-residential. It was a commercial building. Actually, it was an industrial building, so it was very unique. So I worked on a lot of unique projects.
And it's still unusual.
It's still unusual. Yeah, nothing has changed. But no, it's just now what's interesting is I'm starting to work more on non-Passive House projects, but not necessarily like working as involved as I do on the Passive House projects, but looking at how do non-Passive House buildings perform compared to Passive House buildings, looking at utility data and looking at different design specifications and how they're built. Or in the case of some existing buildings, how are typical buildings built and what's the norm for retrofits and things like that. So it's very much like a kind of a comparative sort of analysis in a lot of ways too, between non-Passive House versus Passive House buildings. And then also kind of bridging the gap between buildings that want to get to net zero and use Passive House as a means to get there, but not every project certifies to Passive House. So that's kind of the gamut of non-Passive House versus Passive House.
And the comparative analyses, are those being done for clients, or is that your own research that you're building up?
Yeah, so it's a little bit of both. So clients are definitely interested in how their buildings are performing, particularly building owners want to know how their building is doing and how does that compare to both what the model says and also what typical buildings use. So a lot of it is for the clients. But we are certainly interested in just getting and analyzing this data internally just to know better, be more educated, and really help us inform buildings moving forward. Because we want to make sure that what we're recommending and requiring in some instances are good for the building. So that's a little bit of both.
And what percentage of your projects are existing buildings versus new construction, roughly?
Yeah, so I'd say right now, It's a smaller percentage. It's probably closer to 10%. But we've seen a good growth in existing buildings. And a big part of, I think, where we're at now is sort of this pilot phase, new wave projects that are going to break down the barriers for a lot more buildings to come. So two examples of that are the Hotel Marcel project, which was recently completed and certified. It was completed about a year and a half ago in 2022 and has recently been certified a couple of months ago. So that's going to really usher in all electric hotels. That was a retrofit of an existing brutalist architecture building in New Haven. And then NYU's Rubin Hall project is really NYU's first project at trying to apply Passive House principles with a major renovation project. And they want to sort of translate the lessons learned and translate those Passive House design principles and construction principles to their building stock as a whole. Now, that's a long process, easier said than done, for sure. So I think this Rubin Hall project is going to help usher in a wave of new projects.
And you just gave a talk about the Rubin Hall project. So for those who weren't able to listen to it, can you just tell us, this is a retrofit from the interior?
Correct.
And it's not a historic building per se, in that it's not in a historic district. Is that correct?
I will admittedly say I don't know 100% about every little detail with the historic aspect, but it very much is historic in with regards to subject to historic commissions and certain requirements of maintaining the exterior aesthetic. Windows is a big part of that. So the windows on the project are custom to maintain the same aesthetic look. Now, the original windows were actual double hung or single hung windows. The new windows are simulated versions of those, but they're actually casement windows. So they're much more energy efficient, much more airtight, but they had to look like those existing windows because there are pretty significant historical requirements on the project.
And just backing up to why you chose, or maybe it wasn't named, you're exactly the person deciding, but why an interior retrofit was chosen versus exterior? And I assume it had something to do with preserving the look of that building.
Yeah, absolutely. So that was kind of the main driver, for sure, was we couldn't really touch the exterior brick. Now, there's part of having a building in New York City in general. There's a thing called Local Law 11, and there's a level of inspection and maintenance required on the existing exterior masonry, but we were not able to overclad it with insulation, which is in many cases more ideal from an energy standpoint because you reduce thermal bridging when you can go on the outside and insulate, but we just couldn't do that largely because of the historic requirements for this project. So we had to kind of figure out how to do it all from the interior. And, this is a all electric Passive House building. So it was definitely challenging in how do we achieve this Passive House, the cum laude of energy performing buildings when we can't do anything from the outside.
Right. And by the way, it's not like this is a unique building type in New York City, right?
It's probably a large percentage of the buildings in New York City. I mean, it was built in the 1910s, like it was a pre-war building. So this is, a 100-year-old building. It was originally a hotel. Then NYU bought it, I think in the 70s or 80s. Don't quote me on that, but I know we're recording. But I think they bought it, and have maintained it for at least probably the last 40 or 50 years, and added an annex to it as well. So it's been kind of through the gamut in terms of its utilization and sort of life. So it's going to really take on a new life, I think.
And presumably the solutions that you're applying with this building are going to be applicable to other buildings that NYU owns. So for them, there's a great benefit in addressing this and figuring out how to address it optimally.
Yeah, exactly. So Passive House, from a just overarching design team integration standpoint, is, I think, a concept that NYU is going to apply with all major projects moving forward, or at least attempt to do their best to apply this approach moving forward. And that's, getting the contractor, getting the mechanical engineer, getting the architect, getting the owner, NYU, and getting the Passive House consultant in many cases in the same room very early in a project. So that's one aspect that I think will be applied moving forward. Other aspects being all electric systems, so heat pumps for heating and cooling, and also on this building, heat pumps for domestic hot water generation. So there's a unique design, air-to-water heat pumps that provide heat into a hydronic water loop to the building, of which fan coils provide the heating and cooling into the space, and then also a water-to-water heat pump that takes energy from that hydronic loop to produce hot water for residents. So that is, an approach that may not be utilized specifically every little detail, but basically a heat pump-based heating and cooling and hot water system for projects moving forward.
So does that allow the reuse of the kind of hot, warm air distribution system?
So it potentially could. I think it depends on the condition of the existing piping network. A lot of the existing buildings that we're talking about here are steam heated buildings, and we're now moving to water based systems. So there could be some implications there, but that definitely depends on the conditions. But there's certainly some potential to use existing piping and existing systems to an extent. But there will be, in one way or another, some level of a major retrofit, whether that's adding fan coils, adding water source heat pumps that feed off of that hydronic loop. There's a lot of different ways to sort of take it, but I think there can be a reuse of some existing systems.
And going back to Rubin Hall specifically, has construction started? Has the retrofit started?
Yes, so construction has started. They are going top down, so starting at the upper floor and working their way down, working on the envelope and HVAC, sort of congruently, with windows being one of the first, obviously the rough openings of the windows need to be treated properly, and then the windows get installed, and then ultimately insulation will follow. But yes, construction has started. Demo is well underway, if not mostly complete at this point. Demos of existing interior partitions, things that are going to come out. But construction is underway.
And what's the end date? What's the completion date?
Yeah, so the sort of intent is to have construction complete for students to move in next spring. So very fast timeline.
Whoa.
Yes. I like I said in my presentation, I wish I had a crystal ball, because I'm sure we're going to learn a lot through this process. It's going to be fast. We're going to be under the gun, but we have the right team to do it. So, we're going to figure it out one way or another, but.
Okay. So just to ask about one detail of the project, what's the air tightness strategy for this?
Yeah, so the air tightness strategy is one that has evolved a bit over the life of the sort of design phase of this project. And it was initially thought that we might be able to use the existing plaster as the air barrier, understanding we're going to have to repair it in some locations because it's cracking, but plaster as a specific material is very airtight if it's complete and doesn't have cracks and things like that. However, the envelope consultant on the project, SGH, did a mock-up test of an existing apartment or dorm unit within this building and sort of tested the air tightness and noticed that not only is it not 100% reliable and gives us a bit of cause for concern, but there's also potential that as the contractor makes repairs on the cracks within the plaster, they could actually create more cracking. So, it's like you touch anything, you got to be careful you don't end up breaking it a little more, because these materials are somewhat fragile. So ultimately what was decided was that They were going to keep the sort of existing plaster conditions, not rely on it, and add a 1/4-inch layer of dense glass sheathing with seams taped with air barrier membranes and transition membranes to the adjacent rough openings and the floors to create sort of a more dedicated control surface for airtightness. So it's that sheathing layer with seams taped and transitions to window openings and adjacent floors and ceilings.
Well, that does seem a little easier to guarantee.
Yeah, and it really, and I've heard the Architect FX Collaborative talk about this, that it really, eliminated the variable of how bad are we going to potentially make the existing plaster by trying to actually work on it, or in other words, are we going to end up just kind of chasing our tail by saying we're going to patch up some existing membrane that maybe down the line we realize, oh wow, this is actually twice the amount of work that we thought of. And to my earlier point, this is a really accelerated timeline because students are moving in next year. So by sort of creating this new dedicated control sheathing layer for the air barrier, it eliminated that huge variable that helps ease sort of the tension with regards to how much work this might actually end up being if we just repaired the existing plaster.
And between the windows and the air tightness, those are the big levers that you can turn to try and achieve interfit performance for the building.
Exactly. Those are the big levers. Right now, we think that based on some initial testing of the whole building, that the interfit criteria for air tightness is about 5 to 6 times more airtight than the current conditions. So we know we're going to make this building a lot more airtight than it currently is. And the windows are one huge part of that. We know that the windows that are currently there are very leaky. So just replacing the windows alone is going to go a long way. And then hopefully the combination of that with the installation of this dedicated air barrier system for the sort of the opaque surfaces will help us get there to that interfit level.
Well, there are some happy students ahead.
Yeah, it's going to be interesting to go through this process, and yeah, ultimately it's there to improve the lives of the students, reduce carbon emissions from NYU's perspective, and just make a better building altogether. So, really exciting.
Yeah, it sounds like an excellent project and just one of many that you're working on. But we'll hopefully hear from you more at another time. And it's been great that you found time to stop by and talk with us.
Awesome. Thank you for having me.
Thanks again, Dylan Martello.
Awesome. Thanks, Mary.